Hello and welcome back to the Tin Barn. I'm Pragmatic Lee, and in this week's video we're going to make probably the smallest part or piece that I've ever done out here in the Tin Barn. This is another hayman job, and I kind of like these hayman jobs. This one's coming to me through a friend that I knew back in my archery days. I used to shoot a little bit of competitive target archery. Matter of fact, won a couple gold medals in some senior games and even won the state championship one year. But I'm not sure I got the strength now to pull the bow back. The particular game that I played in archery required 112 arrows per round. And I'm just not sure I got the stamina anymore to pull the bow back that many times. But in any case, a friend of mine from that era sent me a message and said, can you make a part for a friend of mine, friend of his, that was restoring a 34 Ford Roadster. And he needed a piece for the rumble seat. And I said, well, if he can make me up a drawing, I think I can probably, or I'd be glad to look at it and let you know if I thought I could make it. So I gave him my email address and told him it was all right to pass it on to his friend. About a week or so later, I just got this email from him. His name is Dan. I believe that's right. No, I'm sorry, Don. His name is Don. And he sent me a very, very nice drawing. Done some nice CAD work on it. And he titled it a rumble seat step spacer. So what exactly is a rumble seat step spacer? Let's turn over to the computer right quick. I'll try to do a little screen capturing of the computer, and I had to look all this up myself, but it makes perfect sense once I saw his drawing and once I saw a few pictures that I found online. All right, here's the tail end picture of a 34 Ford coupe. I'm not sure what the difference is between a coupe and a roadster, but this assembly right here is the tail light assembly. Here's a closer picture of what I found on the internet. This angle right here, that's what it bolts up to the fender back here. On this end is where the tail light is actually mounted. And this is the step that goes up into the rumble seat. This is the rumble seat up here. It looks like from the pictures I can find there's only one of these on one side of the vehicle. I believe on the left side, looking at it from the back, is where the license plate mount would be, and on the right hand side, looking from the back, is where the step would be. The spacer we're going to be making will go right in here, and as you can see in this picture, there's not even a spacer in there, but it's meant to separate the step from this mounting bracket. This is the drawing that I was sent. As you can see, the outside diameter is only 3/4 of an inch, with the inside being less than a 1/2 inch, and it's only 1/4 inch thick. So this is going to be about as big around as a penny, and maybe about as thick as 4, maybe 5 pennies stacked up. There was a couple things I didn't didn't see on the drawing. One of them is what this angle is. So I printed it out and just extended this line on out and this one on out and put a protractor on it. And as best I can tell, nominal value, that was 20-degree angle. This right here is the area, if anything gives me an issue, this is going to be it. He specifies in the drawing a radius of 0.163. I added a note onto the drawing that amounts to a diameter of 0.326. So I've got something in mind to get a 0.326 diameter in here. The other thing he didn't specify on the drawing was the tolerances. But I noticed that everything pretty much was 2 decimal places. And so I looked up, and you guys remember I'm a retired computer programmer. I just do this machining as a hobby. But I looked online and saw that pretty much a general rule was 2 decimal places. The tolerance was plus or minus 10 thousandths. So I added that onto the list. And for right now, I have blacked out his name, initials, and so forth. Hopefully, he'll give me permission to actually post this. I will not create it, or will not edit this video and post it online until I have his permission to use his drawing and show what we're going to do for him. So let's turn to the computer, over to the mill now, and what I'm going to do is attempt to make this 0.163 radius. Notice, of course, a radius of 163 thousandths, but the thickness is only 100 thousandths. So the center is out here in the no man's land, 63 thousandths out. So I've thought about this a little bit, and I think I've got a way to do that. The outside diameter specified on our drawing was 0.75, which again is 3/4 inch. This is some aluminum 3/4 inch round stock. I've got it mounted in a 5C collet block, and we're going to put our center bore in there. Remember, that was 0.47. I'm going to go a little smaller than that now with a 29/64 bit, which is 0.453. We'll come back to the lathe a little later and bore that out to exactly the 0.47. Let's run our center drill in. I think it'll become quite apparent when we come back over here of why I'm not drilling this and boring this out to size on this first operation. And I'm going to go ahead and drill this maybe 1 inch, 1.25 inches deep, even though our final piece is only going to be a 1/4 inch thick. All right, that should be plenty of material to work with. All right, we're going to turn over to the mill now and get our cross-section holes. All right, if you recall from our look at the drawing earlier, the radius here is 0.163, which is diameter 0.326. Now, I do not have an end mill that is 0.326. A 5/16 end mill is 0.312, which is way below tolerance, 14 degrees smaller, 14 thousandths. The next size up is 375 or 3/8, which is 49 thousandths too big. But I do have a 21/64 drill bit. A 21/64 is 0.328, which is well within our plus or minus 10 thousandths tolerance for this 326 right here. So what we're going to do is drill a hole in our piece out here in, again, no man's land, and then mill all this off, leaving only 10 or 100 thousandths off of this edge. So let's look first at drilling our holes. First thing we of course got to do is get it located on center. I have our work sitting on a parallel here that bridges across the ways on the mill vise, and I also have, or I will, get the edge of our collet block right dead even with the edge of the dynamic jaw on the mill vise. Let's see, get a little higher gear there. And what we're watching for is for this edge finder to kick off. All right, it just kicked to the side, so we'll zero out the y-axis, and we'll come on the other side, and being careful to be the same depth on our z-axis. Now we'll watch for it to kick off again. Now we're on the DRO, Y 1/2. So we can come back to 0 on the DRO on the y-axis, and we can actually lock down our y-axis at this point. We'll use our starter drill again, and I'm just going to get off this edge just enough to know that I've got plenty of room for my 21/64 drill bit, which I do. And I'm only going to drill one side. I'm not going to go all the way through. And the reason I'm not, a drill bit, especially in something like soft aluminum, will leave a nasty burr inside there. And if I run this all the way through, that nasty burr is going to be on this outside here. And we don't want to have to clean up all that. So we'll just go 1/2, or go through one side here. That's why over on the lathe I didn't bore it out to size. We still got what 20 thousandths to go in here, which will clean up that burr. And of course that left a little bit of burr on top, but we all know a common countersink tool will hit these top edges first long before it hits these low edges. So we'll not worry about deburring that little spot right there until we've got this milled down or turned down the length. All right, let's turn it 180 degrees. And I do not have to find center this time because we've already got that. Okay, now we're going to turn it 90 degrees. All right, we're going to locate center again. I'll move in just a little bit so we don't worry about these burrs, but we'll find center again and drill each side. Some of you are wondering why I didn't use a square collet block instead of this hex. I figured it'd be easier to find center one time, refine center one time using the hex block than it would be to put the 4-jaw chuck on the lathe. A 6-sided hexagon collet holder will fit in a 3-jaw chuck. A 4-sided would not. It would have to go in the 4-jaw chuck. I'd had to put that on, and then also had to center that up. My 3-jaw chuck is within 3 thousandths. Actually, it's about 3.5 thousandths. So it should be fine for this project. Now, as you can see, we've got a bunch of burrs inside there. That's what I didn't want on the outside by drilling all the way through. So let's turn back to the lathe now, and we'll bore this, make this inner bore our 0.47 as called for on the print. All right, back at the lathe now. Not sure if you can see it on film, but I marked this jaw with a red marker and marked this flat with a red marker. That way I'm putting this back in, turned the same way, so that should alleviate even that 3/1000 as far as this running true. So we're going to take our smaller boring bar, that 3/8 boring bar, which should fit up in our hole now. Okay, hopefully you'll be able to see a little better now what I'm doing. But I've got the boring bar in there. It'll just barely go. And I'm going to just touch off. All right, that pass right there in itself cleaned up any burrs. Now remember, we want that to be 470. I have a 465 dowel pin right now. So I'm going to take about 10/1000. We're going to hunt for this 465 first. So we're at 450 now. So again, I just want to creep up on that 470. And to begin with, we're going to try creeping up on 465. All right, 465 just barely goes in there. Maybe a little bit of slack on it. So I'm going to zero out the DRO right there, and I'm going to only come in 3/1000. I'll put the 465 pin back up and get the 470. And it won't quite go yet. Now let's try the 470 dowel pin. And I think that's good enough. Just for the sake of it, I'm going to try a 472 dowel pin. And that will just start in this end. So we're well within our tolerance here. Now, so how we're going to get this down to just 100/1000 off that edge. Well, the first thing I'm going to do is take a little piece of fine emery cloth and just run on this outside and clean up just a little bit of those drill bit burrs. Now, if you guys know a better way of getting that down to where we only got a 100/1000 there, remember the center of this is out here at 163/1000, and we only want 100/1000 between this bottom and the edge. If you know a better way, you guys let me know. But what I'm going to do is take the facing tool and just keep facing this off until we look like we're close. Then I'm going to take a 100/1000 dowel pin. Let me grab that right quick and lay in between the facing off and put a flat on this end here, and just keep working down until that dowel pin fits like we want it to. Now obviously we still got plenty to go there. All I'm doing is holding this piece of flat stock up against the end and testing this dowel pin. And it's still loose. I'm using the compound over here on the lathe, so I can't just go in with the cross slide. The reason I'm not using the end of the calipers, that of course has a flat on it, which would not set down would not set down in our pieces or in our valley very well. I can test that right there, and that shows 118 thousandths. But our dowel pin is getting very close. I don't want to move the carriage if I can help it. As Mr. Pete says, like taking your work out, you'll never get it back to where it was. Well, I can back it a little further out of the way. I'm still not feeling any rocking in this flat piece, and my dowel pin is tight now. So I'm going to say that's well within our tolerance of what we were looking for. Now, to get this 20-degree angle here, I'm going to swing the compound around. All right, I got our compound turned around to 20 degrees. I'll bring our tool in. And I should be able to lock the carriage so it doesn't move, and we'll just keep advancing in on the compound. And we're going to want to take this 20-degree right to the bottom of our scallops in here. All right, now that you've seen how that is cutting that, I'll back out. What I'll do is just keep advancing the cross slide in, come back to where I was. Now I'll bring the compound to cut that bevel. Let's see where we are. We are just about there. We'll move just one more cleanup. I'll come in down here about 2 thousandths and take it real slow across here. All right, the drawing said to simply just break all sharp edges. All right, now I'm going to get the compound swung back around, get the tool 90 degrees, and we'll part it off. All right, I've got the compound swung back around now, and I've got the tool post at perpendicular to the work. I'm going to take this little piece of flat stock again, put it right up against the end of our workpiece, and just barely touch the edge of the parting tool on it. Now I'll zero out the DRO and come in 250 thousandths. Lock the table down, lock the carriage down. I'm going to slide my tailstock up here. I've got the chuck in it and got just a little piece of wire to keep this piece from falling down in the drink. Even though this is aluminum, I still like to keep it lubed up when I'm parting. All right, as you can see, parting tool, well, in this case, it broke right off. I started to say parting tool will always leave a little burr there, but this time it broke right off of there. All right, let's swing it back over to the workbench right quick. All right, here's our finished piece. I've got it laid out between a US penny and a US dime just to give you a little bit of reference of size. It's almost exactly the diameter of a penny. I'm going to put this in an envelope, one of the Priority Mail zero tear envelopes. Send that off to the end user and basically put this video on hold until I hear back from him that it's what he wanted, that it works, and also that he gives me permission to use his drawing and his product in the video. Okay, it's been a couple of weeks now, and I heard back from the end user. immediately upon receipt of the workpiece, he said it worked excellent. Then contacted him earlier today. I'm editing this video now, finishing it up for publication in about another week and a half. But anyhow, I finally remembered to ask him permission, and he come right back, granted permission, and let me read his email right quick. I asked him would it be okay with him to publish this video if I block out his name. He said, Lee, absolutely. The proprietary info is just some boilerplate that was on all my drawings when I was in consulting and designing. Now that I'm retired, I don't care. Thanks again for an excellent job, and you can quote me on that in the video. Regards, Don. Refresh you right quick. This is the tail light bracket for a 34 Ford Roadster. This is the step to get up in the rumble seat. And what was missing was this spacer in between here. Don sent me a couple pictures back of it in use. This is his bracket. And as you can see right here is the spacer we made for him. Here's a look at the rumble seat step with it turned upside down, and you can see how those radiuses fit his piece. Looks to me like it fits very well. You guys take care. I'll see you on the next video.